Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 371 maximum strong pair XOR 2. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. So this one, I'm gonna go over the way that I kind of thought about the problem. So it's not a straight up just a solution because hey, you could there are other videos they probably would tell you just a solution, but I'm gonna go over my thought process. And the first thing I wanted to do was just to figure out what this formula means, right? Like figure out the criteria, the candidate for which two pairs can be with each other, right? And so I just kind of picked a random number. I think I picked 500 because it was like the first number here. And I think about all the numbers where this is true. And it becomes a range, right? So it becomes for 500 on the one side you have 1000 because over 1000 the difference is going to be bigger than 500, so it's no go. And then on the smaller side, initially I thought it was 0, but obviously you do a little bit more math, you're like, oh, it's only 250 because after 250 because 250 you what you call it, yeah, 250 times 2 is 500, so you have like 249. The difference is going to be too big, right? So right off the bat, or after a while, me explaining is right off the bat, but after a while, then I'm like, oh yeah, okay. So you could kind of, so you basically, let's say, and you have a lot of numbers, right? So you can't do anything n square, obviously, otherwise this isn't the hard. But once you have these things, then the question is, okay, now you basically have a range of numbers to search for. And then immediately I did a okay, spoiler, but I sort the array because I knew that okay, maybe there's some structure we can do about it. I thought maybe there's some segment tree, just because we've done a lot of segment trees in the past. Maybe it's binary index tree or something like this, but I kind of figured it was a try just because it's XOR, and that is how XOR operates when you operate on greedy. We'll talk about that in a little bit. And yeah, so I landed on try eventually. And then the idea here is, and then I made one optimization, and at least in Python, it turns out to be necessary because my code runs in like 8 seconds. They don't really love Python. I mean, I'm sure I could have written it a little bit cleaner in that, the way that I wrote my code, I use a lot of classes, and I'll show you in a sec. But yeah, but basically one optimization that you can make is that instead of saying a number for number x, you're open to the range x divided by 2 and x over 2 for what we said in terms of this formula, right? You can actually just make it some asymmetric, meaning you only look up the higher number because this is a pair and ordering doesn't matter. So that means that if you have, for example, 25 and 50, if you have 50, you don't have to look at the 25, you can just look forward, right? So then now we reduce the range so for a given number x, we're looking to maximize the XOR from x to 2x, right? So that's one. And yeah. Okay, and that's basically the idea. We'll go over the second part as we go over the code, but let's go over the solution part first, right? So basically here, as we said, we sort the numbers just to give it a structure. That's just and then we create a try. So here we basically have a sliding window, right? We keep on sliding things until and in the thing we want to keep the try to contain x, or all the numbers between x and 2 times x. And that's basically the idea. And this is the right just allows me to keep track of the right boundary. You could also have done a queue, I guess, or a deck or something like this, like I do previously, but that's the way that I have it today. Yeah. So first of all, you remove the previous number because the previous number is no longer, well, the previous number by definition is less than x, right? I guess it could also be exactly x. I don't know if they're unique, but it doesn't really matter because even if they're exactly the same, then it doesn't really matter because you already have one copy and you only need one copy because you can choose same integer to form a pair anyway. But yeah, so you remove it, and then here this is just expanding the sliding window so that it is everything within x times 2, as we said, right? So we add it to t, to the try, and then we go to the right, and then we have a get max function. We'll figure it out. or we'll go over together, and then we have best. So what do we have in our try? A lot of this is very standard try stuff. So if this is confusing for you, definitely do a basic try tutorial and stuff like this. I'm just going to go over the modification on the basic try. Yeah. So the add function is just one thing I want to do is set up the try is not just using a try. What we're doing is call a binary try. Basically, it is just a regular try where each node can have two branches, if you will, one for 0 and one for 1, right? 0 and 1, right? And that's pretty much it. So you can kind of do something a little bit funky that way, but yeah. So initially we declared the root. That's what it sounds like. And here, when we add, another way to write add, maybe I could have just actually reduced this code to just like an increment. But yeah, we have an add where we just add the count to +1. Actually, I guess I could have changed the code a little bit to make it slightly more tight to have just like a counter thing. But in any case, this is what I had during the contest. But yeah, this is for adding 1, right? And basically, this is just traversing down the try. So if this bit is true, then it goes to the true bit. Well, if it doesn't exist, we create a node. Otherwise, we traverse down that bit and we increase the count on that node to 1, right? So we increment on every node. So another way to think about it, and I'm going to actually take out drawing pad real quick to kind of visualize, right? And I'm not going to draw all 20 digits, but and this is hard for me because I'm using touchpad. Sorry, friends. And I also have to put it on screen. Yeah. So basically, this could be 0 and 1, right? Just more nodes. Let me actually use a circle thing, right? And yeah. And then as you and you could create more nodes along the way, but it's always going to be binary, right? And then the idea is that as you add numbers, and this corresponds to the binary number, right? So for example, if you have 7, then the binary bits are on the edge, so that means that this is 1, 1. Whoops. 1. Let's keep it consistent. This is 1, and there's a 1 here that goes to the node, right? And then the idea is just to increment it so that now this is saying that at this node there is 1 element. And that's basically it. That's the keeping track of the try. We'll go over the get max later, but that's keeping track of, okay. So that means that there's 1 number at 7, and also along each of the steps of the way, we also have a count, right? So that means that this has also 1 number in its subtree, and this has 1 number in a subtree, right? And then let's say you add another number, let's say 4. So 4 is what? 1, 0, 0. So that means that now this is a 2. This goes to 0. This is a 1, right? And then another 0. And so this is also a 1, right? And now you have a 2 here. So that's basically the idea. And then deleting 1 is exactly the same. So if you have a window, subtracting it from the window is exactly the same, but I'll just subtract 1 in the same idea, right? Okay, good so far, hopefully. Let me catch a breath if you don't have to catch a breath. But yeah, so that's the add and the removal, and then now to get max. How are we maximizing the XOR, right? This part can be a little bit tricky if you haven't seen it before or done it before, but it's also not super hard. It is, it is, if you've gotten to this step, it's not super hard, but obviously there are a lot of steps along the way. It is just optimizing the greedy part of this. So let's say now you have let's say you have the number 2, right? So 2, of course, is equal to 0, 0, 1, right? Yeah, drawing is kind of hard. Oh, wow, I am bad at binary. It's 0, 1, 0, sorry friends, in 3-digit binary, right? So then what does this mean? So let's say we're trying to maximize this, right? Or we're trying to maximize that formula of having an XOR. with 2, right? 2 and then some other number we have to maximize the XOR result of, right? Okay. What does that mean? So that means that, well, let's just try. So with XOR and maximizing numbers, there are a couple of properties that you have to practice, and if you practice, you'll just know and realize immediately. That's how a lot of the top people get it very quickly. But one is that with XOR, the most significant bit is the thing that dominates, right? Meaning that, like, if you have a 1 the earlier on, it doesn't matter what the rest of the number is. And it makes sense, right? That's because you can think about it in base 10. If you have a million in the most significant digit, then it doesn't matter if the other ones are all 9s. Like 1 million is more than, 999,999, right? It doesn't matter what the rest of it is if you have a 1 in the right place. And so XOR is the same idea, right? So now let's say we have the number 2 in this graph and we have this thing. So what are we trying to do? And we have some, question marks, and we're trying to look for this in the database, and then we're trying to maximize some number, right? So obviously we would love the number to be 1 here, right? And then the question is, well, if this is 1, that means that, and given that our input numbers is 0 in this digit, we're going to search for a 1. Is there a 1? If they, and here we go, oh, there are 2 numbers that starts with a 1, so we could go down this path, so that's good, right? And then the next number, we were like, okay, we would love to have a 1. So 1, oh, actually there is a 0, right? So that's good. So 0, that's good as well. 0, like we would also like to have a 1. Is 0, so we have a 1. But there's no 1 in the 0 node, since this is 0, so we have to take a 0, right? So yeah, you have to take whatever is available. So then now maximum XOR is this thing, which is going to be 6. And we don't even care about this number, though this number is apparently 4, right? And that's basically the idea, is that greedy step every step of the way using trie. And with that in mind, this is how we get to find max. We have find max, we have the answer, we have the bit, and this is just to find the number, to keep track of the number. I could probably have actually did the answer in a different way, but that's besides the point. But basically this is saying, okay, if we can go down that path and that path has at least 1 number, then we can go down that path. And then we just keep track of, like, okay, with if this number is 0 and this number is the opposite, then what is it, and so forth. So this is just bookkeeping, and that's pretty much it. That's what this code does. And then at the end, answer, it's going to contain the number that you're looking for, and because we're trying to maximize the XOR, we just do the XOR again, because it should already be maximized. And that's pretty much it. So what's the complexity here, right? This is n log n, and then everything else is n times L, where L is the size of the L is the number of bits, right? And the number of bits here is they say the input is 20, so 20 or 21 should be fine, I think. But yeah, but still, like, a handful, right? So, and that's pretty much it. This is O of 1, this is O of 1, and remember each number can only be added once. So even though this is a while loop, this is going to be O of n. So yeah, O of n here. Well, O of L, if you want to call it that, but either way, and O of L here as well. So O of n times L is total, and this is n log n. So the time complexity is going to be O of n log n time plus n times L. You could always, you could also say that technically by sorting, you need each comparison is O of L by the number of bits. You're probably right. I don't know. At some point, it gets too complicated to kind of, so I'll leave it up to you to figure out how deep you want to get. But that's what I have for now. And space is going to be O times L. O of n for num sorting. Again, I guess that's O. But yeah, and the trie will take O of n times L. So yeah, that's pretty much all I have for this one. Let's look at the code together one more time. So the node class doesn't do much. It's just an edge to 0 and 1. And then I just have a count. Here's to add and remove. You can have, like I said, you could have kind of convert this into the same function, just change to plus minus 1, and then here's the max function, and of course this is just a kicker function, and that's pretty much all I have. Ooh, what did I do? And that's all I have. So yeah, and you could watch me solve a live contest now. 1, 2. I'm not confident about this one, but I feel like it should be okay. Okay, the 1000 is such a tricky thing, but all right, let's go. Maximum strong. Oh, this is Q1 or Q2, right? And except for the numbers can be pretty big. Well, only up to 1 million. I don't know why they write it like this. It's kind of almost like it hinted at something, but n is pretty big too. All right, what am I doing? So strong pair. What makes a strong pair? Do I have any hints on how people did? Are people already finished? People have done it. So apparently I'm 9th, but so with itself, right? This is one of those pen and pencil things that I need to write. Okay, so best is going to be at least 0. You're so smart, Larry. So the XOR doesn't even matter yet. We have to find the strong pairs first. What's a strong pair? Strong pair. So 500, for example. Okay. 500 is a strong pair of everything from 0 to 1000. Okay. 520 is a strong pair with everything that is. Wait, is it at least? Yeah. So. Well, is that true? No, it's 250 and a 5 and 1000, right? So half and 2x. Because of it, it's like 200, and the difference is obviously too big, right? So yeah, so the number half and double. So then in that range, you have to find the maximum XOR. Maximum XOR. People really got this in like, well, I guess they did spend an entire Q1 on it. Okay, and we can always look forward because looking backwards doesn't make any, like doing half doesn't make sense because we already done that work already. So let's say we're only searching for from x to 2x, right? And then now trying to find a maximum XOR between, say, a number and all the numbers between this and 2x. So maximum XOR within a range. And is that a sig tree again? It was sig tree again. Please don't. I feel like there's nothing but sig trees because people are not being creative anymore. They're just like, we can't figure out anything hard enough that is basic. So let's just do sig tree. But is it? I mean, alternatively, it may just be try. Actually, I don't know how to do. How to use query for the largest XOR within a range. So let's say you have 500, right? 500 by itself is not going to be good. 500 and 520 is 10,000. Why is that? What is... I need more visualization, that's why. I don't know. I don't have my pencil and paper and stuff. Okay. So I guess that makes sense. There's a lot of just non-overlaps. In fact, almost perfectly so. That's actually kind of cool. I guess 512 is the thing, right? So I mean, there is a sliding window thing, right? So we can definitely do a sliding window thing, but and if the number is big enough, then you have to scan all the numbers. If it's just 2x, so because the range makes it so it's gonna be n squared if so we can't just do it. I don't think naively works. But let's sort it for now. Okay, so let's say we have sliding window and you have all these numbers. What do we do? It's just a dynamic try, and we just sliding window. You do a query. I guess so. And you do an XOR. Okay, I mean, I think that's right. That's kind of hard to do. It's hard to do in like 10 minutes, but people are smart, so and A-Wise is up here. Yeah, I mean, if I could think of it, then I guess people think of it much quicker. So, okay, so I have to, do I have a try class? Let me look it up. I think I have template code somewhere. I don't like using it, but I'm also just lazy. It's actually not that hard to write, but maybe I don't. Maybe a try is too straightforward for me to have code. All right. Fine. Okay, so basically just a try with an add and a dictionary, right? So okay. I mean, if you have library for this, this is probably already done, but okay, yeah. I'm so lazy. Okay, fine, just write it out. Write it out, you got this, Larry. What is he gonna no? I worry also a lot about creating too much structure sometimes, because I feel like Python gets penalized in this on Leetcode is why. Like it may time out. It was 5 to 10, 50,000. Maybe it's okay. Should be okay. If not, then I blame on Leetcode, right? What was it? Trying to think whether I could cheat, but I don't think so. Right, so then now maybe that's all I need, right? Uh, 20, fine. Oh, I guess this is a binary thing, so I can just do right. If we want the most significant bit first. Okay. Okay. Yeah. Yeah. So right. So bit is equal to this thing, and x, right? if current.edges of bit is none, then current edges of bit is equal to node. And we want to increment, so current.count is equal to 1 first, and then we traverse down. I think in the root part it doesn't really matter, but we still need to do it here after we traverse. Yeah. Right. Okay. And then delete or remove. Then we do the same. This should not exist. Yeah, okay, right. And the other thing is just max, right? So we have to find max of the current number, right? And then basically current is equal to self.root range of max. This is the bit, right? And to maximize it, so if current of edges of the opposite of this, if this dot count is greater than is not none and also greater than 0. No, we have to do answer 0, 0. Then we take this bit, right? And then if the 0 exists, then it doesn't do anything. Yeah, well, yeah, okay. Oh, this is wrong. This is yeah, I have to make it binary as well. And we have template, this would already be done. Okay, and then this is true, right? So then now this is and you always have it yourself, so it should always be, so there's always going to be a path, right? Current is equal now so then otherwise it put on this side, so do or it's this but the opposite, right? So if bit, then if not bit, this is very yucky, right? Anyway, and then now, okay, for okay, so n is equal to length of nums, right? So for I, X, and enumerate nums, call it index, right? We want to first, we want to we want to keep on adding in the future. So so right is equal to 0. So while x times 2 is So while num sub right is less than or equal to x times 2, then we add less than n and this, and then we want to add num sub right to the try, right? Try is equal to try. Oops. And then we want to add it to the try. Right, and then index means that the previous number gets removed. So t dot remove num sub index -1. As long as, you know, index -1 is greater than equal to 0. And then best is equal to max. Best find max, or t dot find max given the current number, which is just x, right? And that's after we added all the numbers. In theory, this is structurally correct, but it is actually correct. Well, it's telling me it's not. So, yeah, all right, let's, I mean, we have to debug it, but I think this should be right, the idea. Maybe. I feel like maybe I'm just wrong on this. But I think this is not that bad with a template, but yeah. It is what it is. Alright. So we add 1, add 2, max of 1. We get 2. Is that right? Probably, yeah. And then we remove 1, we add 3, we add 4, max of 2 is 4. Is that true? I think 4 is the answer, but not the max. Okay, so is this x, right? Seven zero. Okay, so I think we were right actually. It's just that I returned the wrong thing. Okay, am I confident? Not really. If anything, Leetcode, you know, sometimes gives me a TLE for using Python, so we'll see. But the idea should be right, and the complexity should make sense. So I'm going to get a TLE because I'm using Python. Oh, so I'm wrong about that one. Why? Am I getting? That is actually weird. I also expected this to equal 0. So maybe there is some funkiness going on. Yeah, I mean, that's a little bit sad. Let's see what the debugging is, but that's sad. So 1 max, 1 is 1? Why? Tell me why. So answer is 0, but why is answer 0? Answer is 0. Right? Do I have an off by 1? Is it supposed to be 20? That would be funny. Alright, so if I is 0, yeah, this is off by 1. Alright, well. I was just being lazy actually. I didn't really think about that for a little bit. Okay. Alright, let's give it a submit again. Hopefully now I don't time out. If it times out, I'll be sad. Because I think this code mostly works. Okay. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, today's contest, this explanation, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.